The Auglaize hydroelectric plant is located south of Defiance, Ohio, on the Auglaize River. It was constructed in 1912 and has had a long and interesting history. At just over 100 years old, the hydro plant is looking better than ever and producing cost-effective, renewable energy for a new generation of Bryan citizens. To celebrate the Auglaize plant's centennial, Bryan Municipal Utilities offers this historical look at the plant's first 100 years. In 1904, M.W. Steinberger and John Frost envisioned a dam and hydroelectric plant on the Auglaize River just south of Defiance, Ohio. In June of 1911, their dream started to become a reality as investors from Toledo and New York saw the potential benefits of utilizing the river to produce hydroelectric power. The Auglaize Power Company was incorporated for $1 million and immediately took over the options on the land and power rights that had been secured by the original promoters. The Auglaize plant was one of 4 proposed plants to be built by the Auglaize Company in northwestern Ohio. The second one was to be constructed near Oakwood, the third at Melrose, and the fourth one near Antwerp. The Defiance site was chosen because at that point the Auglaize River drops 4 feet to the mile. This plant was expected to furnish a constant supply of some 4,000 kilowatts, 1,600 of which was to be used by the city of Defiance. Newspapers and prominent citizens welcomed the new project as a means of reducing the high lighting rates and to attract new industries to the city by offering cheap, abundant electric power. On July 21st, a short month after the power company's inception, the Amberson Hydraulic Construction Company of Boston, Massachusetts, was hired to construct the dam and powerhouse. The actual construction work started in late summer 1911, and with a workforce of 103 men, continued through one of the coldest winters on record. Temporary buildings were erected on the east side of the river, including lodging and dining facilities for the workers, an engineering office, and a portable lighting plant with steam boilers. All of the materials were hauled to the site from the railroad by horses. Construction went on day and night, and it progressed rapidly. Reinforced concrete was sunk into the limestone bed of the river at a depth of 11 feet. The hollow construction concrete dam was designed to be 500 feet long and 22 feet high, while the powerhouse was 100 feet long. At the same time as the construction of the dam and powerhouse, a transmission line was built along the river through Defiance and on to Toledo to hook up with the lines of the Toledo Rail and Light Company. The dam and its powerhouse were completed in the summer of 1912 at a cost of $500,000, and electricity started flowing to the city of Defiance and local manufacturers on October 31st, 1912. Less than 2 weeks later, the Defiance city attorney filed an injunction on behalf of the city council to restrain the Auglaize Power Company from overbuilding distribution lines in the city. The Auglaize Power Company decided not to fight the case and built transmission lines around the city, cutting out Defiance from receiving power from the hydro plant. Defiance went back to using steam power. Pressure from the local manufacturers who had been using power from the dam led to a franchise being granted to the Auglaize Power Company to build transmission lines in the city, and the injunction was dismissed in November 1912. By January 1913, the Auglaize River Power Dam supplied both Toledo and Defiance. In March of 1913, days of heavy rain over frozen ground sent a large volume of water down the Auglaize River and over the top of the dam. On the morning of March 26, the earthen embankment along the west side of the river, forming the wing to the power dam, gave way to the great force of the water. The river practically changed course to get around the dam and through the embankment. According to the Defiance Crescent News that day, people in the city of Defiance thought the entire dam had washed out, and the courthouse bell and fire bell rang as a warning. However, only the embankment on the west end of the dam, not the dam itself or the powerhouse, had given way. The flood cut out a 120-foot section in the earthen retaining wall, which had a cement wall that ran through the middle and rip-rack rock on the riverside. The road on the west side of the river was also washed away. Flood damage to the Auglaize Power Company's equipment and dam was estimated at $24,000. About a week after the flood, workers began making temporary repairs to the wing wall to get the plant operational again, while plans for building a more substantial structure were being formulated. Workers began filling in the 120-foot gap while a permanent wall could be constructed. Plans called for extending the dam 322 feet in a straight line from the powerhouse, making the new length of the dam 792 feet instead of 470 feet. A new contract was let for rebuilding the retaining wall. A cofferdam was placed in the break, and although repairs were not yet completed, the Auglaize was put back in operation on July 17, 1913. The break in the retaining wall was filled with a 150-foot concrete wall, 15 feet wide at the bottom and tapered to the top. It was one of the largest concrete jobs in Defiance County. The concrete work was finished in August, and there were no further breaks in times of flood. In the spring of 1913, the New York investors bought the Defiance Gas and Electric Company, thus combining under one management the Auglaize Power Company and its affiliates. The Defiance Gas and Electric Company served Defiance, Maumee and Perrysburg, Grand Rapids, Weston, and the Wildwood Addition in Toledo. In May 1924, Toledo Edison Company applied to the State Utilities Commission for permission to buy all properties of the Defiance Gas and Electric Company, the Swanton Light and Power Company, and the Holgate Light and Power Company. The price for the group was stated as $2,507,500. The purchase was approved, and Toledo Edison acquired the Auglaize and Maumee hydro and steam plants, a total of 4 production units. Transfer of the properties was effective June 1, 1924. The Toledo Edison Company operated the Auglaize hydroelectric plant until December 12, 1962, when it shut down the plant. Edison's Defiance district manager explained that the company had ample supplies of electricity from newer, more efficient coal power plants. The hydro plant was abandoned and the generating equipment removed. In 1967, with urging from the public and area state representatives, the Ohio Department of Natural Resources offered to purchase the Auglaize Dam and land holdings along the river for use as a recreational area. The offering price of $100,000 fell short of Toledo Edison's asking price of $300,000, and the offer was rejected. The plant sat vacant until the 1980s, when the city of Bryan started looking at it. In December 1981, Bryan Municipal Light and Water Utility, now Bryan Municipal Utilities, filed a permit with the Federal Energy Regulatory Commission, or FERC, in Washington, D.C., to study the possibility of using the abandoned Auglaize River Dam to generate hydroelectric power for its electric customers in Bryan, Ohio. The Bryan Board of Public Affairs instructed a public utility consulting firm to file the permit on behalf of the city utility. Leon Daggett, Bryan Utility Director, said the Auglaize River project had become feasible because of the soon-to-be-completed Marquis Corridor project, a 10.5-mile electric transmission line from an Ohio Power substation north of Sherwood to a substation near Bryan. At that time, Bryan purchased its power wholesale from Toledo Edison Company, but planned to switch to Ohio Power Company once the Marquis Corridor was completed. Ohio Power had a substation across the road from the Auglaize hydroelectric plant, and power could be transferred over Ohio Power lines from the plant to the city of Bryan. A study in 1982 revealed that purchasing and refurbishing the hydro plant may be too expensive for the city of Bryan to finance on a long-term basis. In 1984, Toledo Edison sold the empty facility to Power Dam Corporation, a 3-person company from Fort Wayne, Indiana. Power Dam Corporation put generators back into the plant and started producing electricity at the site again.
When we got here in 1984, I'm not sure there was a window in the building, and there was pigeons had taken over the inside of the building, and it took us about a week to clean that mess up. There's a big long trench in the powerhouse where the cables, the power cables and things went in. And there's a diamond plate, steel diamond plate that went on top of it. Half of those plates were thrown down in where the machines were disassembled. It's probably 60 feet down there. We had to get all that stuff out of those holes. We had to clean all the excess concrete and, of course, excavate a lot of concrete to accept the new machines that we were bringing in. And so it was It was quite a chore. The first year I had probably 4 guys plus myself working here. A lot of concrete to break out, a lot of concrete to pour, some formwork to build, to make to accept the discharge ring and the bottom ring. There was a lot of manual labor the first year. Now the machines that we first put in here came from Sault Ste. Marie, Michigan. They were in an Air Force base at a place called Kinross, and it's an old Air Force base up there in the UP of the Sioux, or Michigan, and the machines came from the Canadian side of the river up there, and there was, I'm thinking, 25 machines in that powerhouse, and they were all disassembled by a company out of Massachusetts and stored up there, and then they were selling them just piece by piece to whoever wanted to buy them, whoever needed them or whatever. And the guys that ran Power Dam Corporation, Steve Schmidt, Steve Adair, Angelo Stravakakis, and Bill Lee were the 4 owners of Power Dam Corporation then. And they ended up finding these machines and ran up to the Sioux and loaded a few machines on trucks, drove back down here, was down here the next morning to unload the machines, and we did that 4 times. The gates, as far as I know, were original. They had the original, well, I can't say that the electric motor was original, but it had been here quite a while. But all the drive paraphernalia that went with the electric motor to raise and lower the floodgates was original whenever they put this thing in service. The concrete was in bad shape, the floodgates, and the dam itself was hollow underneath. If you're looking out from the downstream side, you can see that the dam is all solid. Bryan Utilities filled that all in over a few years. The head gates are original. The trash racks were in very bad shape. We did some repair on them. The first year we lost probably 4 of them due to ice flow. And if you look at some of the pictures, you can see the walkway that went out along the upstream side of the dam. And the first year we were here, we had about 10 feet of ice piled up on that walkway there, and it destroyed, I'm thinking it was 4 of our trash racks at that time. So that was a rebuild the next summer we had to do.
In September of 1996, the Bryan Board of Public Affairs gave the green light to Bryan Utilities Director Kevin Maynard to purchase the Auglaize hydroelectric plant for $1,115,000. Bryan's Director of Utilities, Kevin Maynard, said the Auglaize plant was a better value in 1996 than it had been in 1981 since the generation equipment was in place. The cost of generating and transmitting the power to Bryan was estimated at around 2.5 cents per kilowatt hour, below the city's average of 2.9 cents at the time. The first improvement to be made was an interconnection between the plant and American Electric Power, formerly Ohio Power, which provided transmission access to Bryan. Until the new interconnection could be completed, the hydro plant's production was sold to Northwest Ohio communities connected to Toledo Edison. The substation and interconnection to American Electric Power were completed in September of 1997. Total generation for the plant in 1997 was just over 7.8 million kilowatt hours. The plant had 4 generation units in operation, with a capacity of 3,500 kilowatts. FERC required the city to install a 5th unit and flashboards. Flashboards, wooden extensions that fasten to the crest of the dam, would raise the level of the water in the reservoir 2 feet. This would allow the city to pool water and generate when Bryan's peak load was high. Bryan Municipal Utilities faced numerous capital-intensive improvements that had to be made to the plant, but it was considered to be a valuable part of the city's power supply mix for many years in the future. The utility spent the next few years restoring the plant's condition.
Well, originally we had the feasibility study that we knew what we were going to do with the dam and what repairs we were going to make, because things were in pretty rough shape, and we were going to do a number of things to make it last 30 years. I mean, where you saw the deck out here, we were just going to bring in concrete slabs and lay over the existing piers all the way out there, and then the gate area was going to stay the same. We were going to make certain repairs out there to the gates we had, but they were going to stay the same. Okay, there were 4 generators here that came from Sault Ste. Marie, Michigan, and those are the 650s in there that were just rewound recently. So there was a spare unit, complete unit down here. It wasn't in very good shape, but the stator and the rotor were good. So as the generators were rewound and stuff, just kind of kept rotating those machines out. I was able to find there were a generator up in Maine. It had changed ownership, and they were taken out of a paper mill in Canada someplace and didn't have many hours on them. I went up and looked at those with the engineers that helped design all this. We made an offer on one, and then talking to the engineer, he suggested we make an offer on both of them. We were actually able to buy 2 units for what we were going to pay for one.
In 1998, BMU installed new switchgear controls for the generators and a new battery system to run the controls. The city utility also installed a water level sensor with an alarm system connected back to the Bryan power plant. On FERC's orders, crews repaired the crest and began filling 3 of the 10 hollow bays under the dam with concrete. To provide access for construction and concrete trucks, a new gravel road was built on the west side and brush and trees were cleared from the dike. Crews also started replacing the boarded-up windows. The Auglaize hydro plant got off to a rough start in 1999. Heavy snow was followed by an overnight warm-up to 65 degrees. The rapidly thawing snow caused a sudden rise in the water level and moved a large flow of ice downriver and into the front of the power plant and the floodgate piers. The ice impact damaged the gates, trash racks, and concrete structures.
They estimated the ice probably hit at about 35 miles an hour. And what happened is the ice had got caught up here at 5-span bridge, and people were complaining about the water backing up behind the ice at the bridge. And they were asking us to open gates to relieve some of the water. Well, we didn't have any water down here, apparently because it was all backed up. But when we opened the gates, it changed some flows on the river, and all that ice broke loose. So it was just a wall of ice that came down the river and hit the dam. It broke one of our gates out there, broke the chains on one of the gates, which they feel may have helped Defiance out because that gate shut, and those gates passed quite a bit of water. The problem we had is when we started looking, our forensic engineer came in and said the only way you know how much damage you have is to tear it apart. So because of safety issues and everything else, it didn't leave us much choice because we didn't know the extent of damage. And with FERC involved and everybody involved in the impact, the only thing we could do is tear it apart and see. And it came apart pretty easy. So there was, stress cracks in it and that sort of thing. I think the building part was all right, but out there in the spillway, I think is where most of the concern was at.
To make repairs, the turbines and intakes had to be dewatered. New design of the trash racks and floodgates was recommended to improve plant operations and safety, and the ability to perform gate and turbine maintenance. Due to lack of rain and the damage to the intakes, production from the plant in 1999 dropped to 3.45 million kilowatt hours. Repairs, upgrades, and capital improvements continued through 2001. Demolishing and reconstructing the intake and trash racks and installing spillway gate anchors in the north wall of the powerhouse were completed in July 2000. The 3 floodgates and piers were demolished and removed. To reconstruct the piers, 250 cubic yards of concrete were poured around 46,000 pounds of reinforcing steel to a total height of 35 feet. By the end of 2000, construction of the 3 new spillway gates and piers was completed, and 3 new spillway floodgates were installed. The plant generated almost 5 million kilowatt hours in 2000, an impressive amount considering only 2 units were available for operation, and a large amount of water was passed through the gates to protect the repairs. In 2001, the intake and trash racks for generating units 1 through 4 were rebuilt, and the piers and decks were constructed. Each unit was rewired and connected with new switchgear as it was taken out of service for the intake repair. The repairs were completed by October, and the city opened the Auglaize plant to the public for the first time. Nearly 400 people took advantage of the opportunity to walk around the plant floor and inspect the turbine generators and the SCADA-equipped control room. At that time, the plant was equipped with 3 Westinghouse generators rated at 650 kilowatts each, and 1 Westinghouse generator rated at 1,750 kilowatts. The plant generated 4.4 million kilowatt hours during the year, even though there was construction through most of the year. In May 2002, lightning struck the Auglaize plant and caused 2 generators to catch fire. Fortunately, at the beginning of the year, Bryan Municipal Utilities had purchased 2 used 1,420 kilowatt turbine generators to install in a bay that had been empty since the 1960s when the plant was dismantled. 1 unit was repaired, and the other generator would be replaced with one of the recently purchased units.
The damage on that unit just wasn't, there was just no reason to fix it. We could install those other 2 units cheaper than we could actually rebuild that other unit, make it efficient enough to actually operate in a plant at a reasonable capacity and use the water.
In September, the utility acquired a small generator to take advantage of minimum flow for generation.
What we ended up doing, even with a little unit, is we installed units in here with a real variety of flows and the way they're set up that we can utilize the water very efficiently.
To reduce the risk of further damage due to lightning, BMU had the hydro plant and related equipment tested for adequate grounding and installed lightning arresters for all units in operation. In the spring of 2002, BMU crews installed flashboards on the crest of the dam, and the additional pool of water was used to improve generation. For the year, the Auglaize plant generated nearly 5.4 million kilowatt hours, which was better than expected, with dry weather and only 2 or 3 units available for generation during the majority of the year. At the end of 2002, the utility purchased a trash rake to remove debris from the intake trash racks and installed it in early 2003. This improved efficiency because the plant did not have to be shut down to clean the trash out of the racks. With the rake, the crew could clean the racks more often and maintain maximum output of the units. With 3 generating units operational, the plant produced just shy of 9 million kilowatt hours in 2003. The Auglaize hydroelectric plant had a record year of generation in 2004, producing 9.33 million kilowatt hours, or enough to supply 950 average homes in the city of Bryan for an entire year. During the first half of the year, only the 3 original units were generating. Plant operators installed a 140 kilowatt generator for low flow periods and 2 larger 1100 kilowatt units, one that replaced the fire damaged unit. By the end of the year, the plant was operating at full capacity for the first time since the early 1960s when Toledo Edison closed the plant. There were 2 large generators, each capable of producing 1100 kilowatts, a smaller 140 kilowatt turbine used for minimum flows, and 3 other 650 kilowatt units at the plant, for a full capacity output of 4,290 kilowatts.
This unit number 5, this is the last of our major rebuilds that we've done. We completed that unit in the spring of 2013. Basically, we went through and had some major issues with the larger machines. Through the years, we've broken some large 8-inch diameter main shafts that are connected to the runner to the generator. So when we determined that those shafts were broken, we decided to go ahead and do major rebuilds on those units. The rebuilds consisted of sending the stator and the rotor out for rewinds, where they stripped all the old copper insulation, put new copper, new epoxy insulation on the machines, and then we sent out the runners to be balanced, cleaned, and new shafts built for them. And then we had a ceramic coating put on those runners also to give them a lot longer life and to improve the efficiencies. Basically, the rebuild started from the bottom all the way up through the machine. We stripped everything out then started reassembling with new machine parts, and basically we changed some of the design changes that were put in when the machines were reinstalled in this plant in the 80s. We had some different design that the company who reinstalled them tried that didn't seem to work too well. So we took the machines and put them back to their original design. We made a few adapters so that we could mount the bearings on the head covers and so forth. And then the shifting rings and so forth, we changed to actuators that are mounted on the plant floor, basically putting them back the way they were when they were installed in the early 1920s. And since that time, we've had real good success with the machines. We've taken them from their initial rating of 650 kilowatts to now we're at 800 kilowatts. Units 1, 4, and 5 can all run at 800 kilowatts.
They also built and installed a new headgate system, which gave plant personnel the ability to open and close the turbine headgates much faster, allowing units to come online quicker. The headgates could also be shut down quicker to conserve water for generation. In 2005, Bryan Municipal Utilities purchased a used workboat to facilitate installing the flashboards and performing maintenance on the gates and racks. Auglaize employees refurbished the boat and added a small crane. An equipment storage building was constructed along with a concrete apron to allow the trash rake to be moved into the building. The final FERC requirement to fill all the hollow bays in the dam with concrete was completed in 2005. Even though 2005 was exceptionally dry, the Auglaize plant was able to produce about 9.7 million kilowatt hours for the year. Bryan Municipal Utilities was finally realizing its vision of developing the Auglaize hydroelectric plant. With all the units running and a very good year of precipitation, the Auglaize plant was able to generate a record 13,637,035 kilowatt hours in 2006, which equated to a savings of nearly $700,000 on the city's American Electric power bill. It was enough energy to supply approximately 1,337 average homes in the city of Bryan for a year. Record-setting drought conditions in 2012 led to a year with slightly less generation from the Auglaize hydroelectric plant. Even with less generation than normal, the price per kilowatt hour was 5.4 cents, considerably less than the 6.7 cents the utility paid for power purchased in the market.
When we purchased the plant, we were purchasing power for about 3 cents a kilowatt hour. And at the time, the cost out of the plant was 4 or 5 cents in that area. So there was a number of people that thought it wasn't such a good deal because it was actually costing us more than the cost of power. But then that cost still remains today the same that it was when we purchased the plant, and will continue that way into the future while the price of power continues to go up. So today it's a much better deal per kilowatt hour than it was when we purchased the plant. Also, we are able to take advantage of the capacity that the plant puts out, and we get paid for capacity on an annual basis. And also when we generate at peak times, it helps control our costs by lowering the transmission cost for the power that comes to Bryan.
On July 23, 2013, the Auglaize hydroelectric plant set a daily production record of 104,287 kilowatt hours. That was enough energy to power 122 average Bryan homes for a day. Rebuilding units 1, 4, and 5 to increase the output from 650 kilowatts to 800 kilowatts was paying off. Hydroelectric power is an emission-free energy source. By replacing power purchased from fossil fuel-burning power plants, the Auglaize plant avoids air emissions of tons of carbon dioxide, sulfur dioxide, and nitrous oxide pollutants every year.
The Board of Public Affairs set a goal to having 20% of our power supply supplied by green energy in 2015. And the Auglaize hydro plant was a large part of that, providing nearly 4% of the city's needs. They have taken a number of approaches to the green energy, such as the solar field, But the hydro plant was really the one that kicked it all off and started Bryan on the path for green energy.
In addition, 2 of the units at the Auglaize are certified for renewable energy credits, and Bryan Municipal Utilities is able to sell the credits in the market. The utility is currently working to certify the remaining units. Finally, the Auglaize plant creates an excellent recreational area above the dam for area residents to enjoy.
The Auglaize hydroelectric facility has a rich and interesting history. We at BMU feel it's our responsibility to provide low-cost renewable energy to our future generations. The facility will be a benefit and an asset to our customers and citizens of Bryan for many years to come.
As Bryan reaps the benefits of its investment, it can be proud of its accomplishment and the role it has played in a century of hydroelectric power in Northwest Ohio.